Production of cathode rays in discharge tube. Discharge of electricity through gases at low pressure. A discharge tube is an arrangement to study the conduction of electricity through rarefied gases. It is a closed strong glass tube of length 50 cm and diameter 4 cm. It is fitted with two metal electrodes C and A, which is given in figure. The side tube P is connected to a high vacuum pump and low pressure cage. The two electrodes are connected to the secondary of the powerful induction coil, which maintains a potential difference of 15,000 volts. The electrode C connected to the negative terminal of the induction coil is called cathode, and the electrode A connected to the positive terminal is called anode. As the pressure of gas in the discharge tube is gradually reduced by working the exhaust pump, a series phenomena is found to take place in succession. They are discussed below and illustrated in figure. Point number 1. When the pressure is about 100 mm of mercury, no discharge passes through the tube. 2 point. At a pressure of about 100 mm mercury, sparking occurs which accompanied by cracking sound. Point number 3. As the pressure is reduced to the order of 10 mm of mercury, the irregular streaks broken out in a luminescence column extending from the anode almost up to the cathode, which is given in figure. The cracking sound is replaced by continuous buzzing sound. This column is known as a positive column. The color of positive column depends on the nature of the enclosed gas. It is reddish for air, bright red for neon, and bluish for CO2, etc. Point number 4. As the pressure is further decreased of about 3 to 4 mm of mercury, the positive column decreases in length. It starts from the anode but ends well before the cathode. A bluish glow is seen around the cathode called cathode glow or negative glow, and there is a dark space between this glow and the positive column. The dark space between the cathode glow and the positive column is called Faraday's dark space. Point number 5. When the pressure is reduced to about 1 mm of mercury, the positive column is further shortened and the length of the Faraday dark space is increases. The cathode glow is detached from the cathode and a new dark space appears between the cathode and the cathode glow. This is called Crookes dark space. Point number 6. As the pressure is decreased further, the Crookes dark space and the cathode glow expand. At about 0.1 mm of mercury, the positive column is split into alternate bright and dark bands called striations. Point number 7. With further reduction in the pressure, the striations move towards the anode and finally vanish. At the pressure of about 0.1 mm of mercury, the Crookes dark space wins and fills the entire tube. This state is known as black discharge. A new phenomena starts at this stage. The walls of the tube begin to glow. This is called fluorescence. The glass tube opposite to the cathode glows with a bluish and a greenish light. It is yellowish green for soda glass. The greenish glow in the final stage of the gaseous discharge was soon found to be fluorescence of the glass produced by some invisible rays emanating from the cathode. These rays were called the cathode rays and were later found to be electrons.